Morning, children. This is Shobal sir speaking. Children, as of now, we have completed the exercise 7.2 as we are dealing with the chapter fractions. So we have already completed the exercise 7.2. So here I would like to start a new exercise of the chapter fraction, exercise 7.3. I drew some figures, as you all can see on my copy. I drew some figures, and we have to find out what the fractions of these figures are drawn. Children, if there are any confusions or the doubts from the exercise 7.2, please let me know what are the problems you are facing. I'll definitely clear out those doubts and confusions. Here, would like to deal with the exercise 7.3. So here are the diagrams. The first diagram, as you can see, of question number 1A, there is a circle, and for this circle, it's divided into two equal parts. And one part is shaded. So there are two parts, means divided by 2. One part is shaded, means it's 1. So it's the fraction of this shaded part of this complete figure is 1 by 2. So the fraction of this complete figure, fraction of this shaded part of this complete figure is 1 by 2. Children, in the next figure, as we all can see, there are 4 parts. It is divided into 4 equal parts, 1, 2, 3 and 4. Out of these 4 parts, 2 parts are shaded. Out of these 4 parts, 2 parts are shaded. So the fraction of these 2 parts out of 4 parts is 2 by 4. I repeat, there are 4 equal parts of this particular circle. So the fraction of these 2 parts out of this total, the total 4 parts is 2 by 4. In the next figure, it is divided into how many equal parts? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. There are 6 equal parts. This particular figure, this particular circle is divided into 6 equal parts. Out of these 6 equal parts, 3 parts are shaded. 3 parts are shaded. So naturally the fractions of these 3 parts is 3 by 6. 3 parts are shaded out of 6 parts, so the fraction is 3 by 6. In the next in the next figure, in the next circle, there are how many equal parts? 1, 2, 3, 4, 5, 6, 7, 8. There are 8 equal parts. Out of these 8 equal parts, 4 parts are shaded. So the fraction of this circle is 4 by 8. Children, the very first day, you all may remember when I had taken up a live class, I had explained about the fractions, how fractions works actually. If I've got a small, if I got a piece of bread and I want to distribute among five students or the 5 people, so what I have to do? I have to make 5 equal pieces. 1, 2, 3, 4 and 5. There are 5 equal pieces. So this is what this fraction is all about. So each part, one part of this total bread is 1 by 5. Next part is also 1 by 5. Next part is also 1 by 5. Next one is 1 by 5. The last one is also 1 by 5. One individual part is 1 by 5. The fraction of one single part of this bread is 1 by 5. Suppose I've got a chapati. I've got one single chapati and I have to distribute among 2 children, among 2 people. So what I'll do, I'll just tear it off into 2 equal pieces. I'll just make it 2 equal halves, and one part will be given to one and another part will be given to another one. So means one chapati can be distributed among 2 people. So each part is 1 by 2. 1 by 2 and 1 by 2. Children, we must remember, we should always keep in our mind, whatever the fractions you are having from one figure, if you add it up, you will get 1. I repeat, as we can see in the chapati, from this chapati, the one individual part is 1 by 2 and this second part is also 1 by 2. So if you add up this 1 by 2 plus 1 by 2, you will get 1. Similarly, suppose as we have the fractions of this one individual part is 1 by 8. This is 1 by 8, this is 1 by 8 and this is 1 by 8. So these 4 shaded parts are 4 by 8. So if you add all this 1 by 8 and 1 by 8, if you add all this 1 by 8, you are supposed to get 1. This is only the interesting facts of fraction. If you add up all these fractional parts, you will get 1. So now in the next question, there are so many questions of this, within this rectangular box. So I have chosen only one question to explain, and the next similar questions to be solved by your own. So let us talk about this one, this particular rectangular box. There are 12 small circles lying within this rectangular box. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Out of these 12 smaller circles, 4 circles are shaded. 4 circles are shaded out of these 12 smaller circles. So the fraction of this shaded smaller circles is 4 by 12. Children, why it's 4 by 12? As there are 12 number of circles, out of these 12 circles, 4 circles are shaded. So the fraction of this shaded circles is 4 by 12. Similar way, we have to deal with the other questions of question number B. I believe you will be able to solve your own. If no, please drop your queries in the WhatsApp group or in the comment section of this YouTube channel. Now let us talk about the next question. This was all about question number 1. Now I would like to discuss something about question number 3. We are given some fractions, some numbers are missing. Some in the place of denominator, some in the place of numerator. So what will be the missing values that we need to find? So it's 2 by 7 and that is equal to 8 by something, and the missing number is within the box. Now my question goes to everyone. When 2 turns into 8? When we multiply it by 4. 2 turns into 8 when we multiply 2 by 4. So if I multiply 2 by 4, with the same number I have to multiply 7 also. Why? Because we are just dealing with equivalent fractions. Equivalent fractions means when a fraction gets multiplied with the same values with the numerator as well as with the denominator. When the numerator of a fraction gets multiplied with a number with the very same number, denominator also gets multiplied, we get an equivalent fraction. I repeat, when we multiply numerator of a fraction with a number with a value, the same value will be multiplied with the denominator as well, then we get an equivalent fraction. So when 2 turns into 8, when we multiply it by 4. So 4 will also be multiplied with 7. 4 sevens are 28. The missing value is 28. Again, when 5 turns into 10, when we multiply it by 2. So same value will be multiplied with the denominator as well. So 2 into 8 results 16. So 5 by 8 and 10 by 16, or 2 by 7 and 8 by 28. All these fractions are equivalent fractions. All these fractions are equivalent fractions. Now the next question number C. The numerator is missing, denominator is 20. Question goes to everyone. When 5 turns into 20? When we multiply it by 4. So 4 into 5 is 20. With the same value, the numerator will also be multiplied. 4 3s are 12. So it's 12 by 20. So the fraction is 12 by 20. Now, in the next question, so children, I have shown only 3 questions of question number 3. A, B, C. I would like to request to all of you to try out all the remaining questions of question number 3. Now, question number 4 is about find the equivalent fractions of 3 by 5. We have to find the equivalent fractions of 3 by 5, in which denominator is 20. So I'll write in this way. 3 by 5 is equal to divided by 20, numerator is missing, because in the first question of question number 4 is asked when denominator will be 20, what will be the numerator? Achha. Or equivalent fraction, same only. I wrote 3 by 5 equal to, I drew a line, denominator is 20. When 5 turns into 20? When we multiply it by 4. So with the same value, the numerator will also be multiplied. It will be 3 4s are 12. So the equivalent fractions of 3 by 5 is 12 by 20. The next one is 3 by 5, same fraction, when numerator is 9. So children, when 3 turns into 9? When we multiply it by 3. 3 3s are 9. With the same number, 5 will also be multiplied, or the denominator 5 will also be multiplied. 3 5s are 15. So 9 by 15 is another equivalent fractions of 3 by 5. The next one, again 3 by 5, I'll draw a line where denominator is 30. Acha. Children, when 5 turns into 30? When we multiply 5 with 6. So with the same number, numerator will also be multiplied. 3 6 are 18. So I got 18 by 30. This is also another equivalent fraction of 3 by 5. Next one is again 3 by 5 when numerator is 27. Children, when 3 turns into 27? When we multiply it by 9. With the same values, 5 will also be multiplied. 5 9s are 45. So 27 by 45 is also an equivalent fraction of 3 by 5. Children, this way we calculate equivalent fractions. Equivalent fractions are nothing. It's all about a fractions. It's all about a fraction just getting multiplied with the same value with the numerator as well as with denominator. If I give an example from myself, suppose I wrote 5 by 11 and I want to just find out equivalent fractions of 5 by 11. Just multiply 2 by 2 and 2. Suppose 5 2s are 10, 2 11s are 22. Again, 5 by 11, I want to find one more equivalent fractions, just multiply by 3 and 3. Suppose 3 5s are 15, 3 11s are 33. Suppose one more 5 by 11, I want to find one more equivalent fractions of it, just multiply by 4 and 4. Similar, in this way, we can find uncountable number of equivalent fractions of a fraction. Uncountable number of equivalent fractions can be found for a fraction. So children, I'm explaining up to this much till question number 4. And the questions which I'm not showing in the video, those questions should be practiced your own. If you get in difficulties, any problems, please feel free to speak to me. I'll definitely clear your doubts. And if there is any confusions, or if you having any problem to understand, please do watch this video again and again. I believe your doubts and confusions will be cleared. Till then, thank you so much, children. In the next video, I'll deal with question number 5. Thank you, children. Thank you so much. Have a good day.